Hello class, so this is a video on today's lesson, which is on 3.5. Today is Thursday, October 27, and you may be watching, those of you who are in periods 1, actually periods 2 and 4, will watch this video probably tomorrow. So this video will bring everything that we've learned so far this unit together, and basically will serve as a review for your upcoming Unit 3 test, which will be on this coming Monday, October 31st. So please pay attention, make sure you watch carefully, you pause, revisit, go back if you need to pause and review some information. This would be good, for the purpose of this video. So with this being said, let's move ahead with starting with warm-ups, okay? So on your own, let's see here, on your own, you're going to complete day 4 warm-up. I'll have you do the first one individually, okay? The first one individual, the first part here, and the second part here with a partner. Okay, so notice in the first example, you're given the recursive formula. Here, this is the recursive. This is the middle part, the mid column here. And here, you're given the explicit, or you need to document the explicit formula or rule. So the first question you're given, you're given the explicit form, the recursive formula. You're asked to find the explicit and to fill out the table. In the second part, you're given the explicit, and then you're asked to complete the table and also write the recursive formula. So take a few minutes, start again individually on the first one, and then once you're done, work with a partner, maybe your elbow partner or the person sitting behind you, to complete the second part, okay? So you can take a few minutes to complete that, and then I'll move on to the next topic here, which is today's lesson on let me clear that up, on 3.5. So the lesson on 3.5, which is on page 37, I believe. Let me see if it's 37, actually before that. It starts here. Okay, right here. It starts right here on page 28. Okay, so this is where lesson 3.5 starts. Lesson 3.5 is going to be no new information really. It's very much a revisit to both arithmetic and geometric sequences. So let's start with number 1. It says find the constant ratio. Now remember, we don't really call it constant. So anytime you see constant is really the common ratio, which is the same thing. So from 2 to 4, you can say I'm multiplying by 2 every time, right? I'm multiplying by 2. But mathematically, it would be nice to say the common ratio is what? Is 8 over 4, which is the same as 4 over 2, which is the same as, right, 16 over 8. And all these are the same value, which is 2. So this is the common ratio. And again, they're only asking you to find the common ratio. They're not asking you to write a rule, not yet. Just find the common ratio. So same thing for number 2. Your common ratio is going to be found by dividing 1 by 1/2, which is the same answer as dividing 2 by 1, which is the same answer as dividing 4 by 2, and so on, which is the same answer as dividing 8 by 4. And all these are going to give you 2. So regardless of which pair of values you choose, if you choose any current value divided by the previous value, that will give you 2, and this would be the common ratio. Number 3, same idea. If you divide 10 by -5 and so on, you don't have to show all of them really. You could also, if you do, oh, I'm multiplying by -2 every time, that's good. That's a good visual, but I think algebraically to show that you need to divide 10 by -5 or 20 negative 20 by 10, and so on. Okay. So this helps us find the common ratio, which in this case is going to be negative 2. This is R equals. Okay, remember when they ask you to find the common ratio, you have to document it. R equals, not just write 2, R equals to 2. And if it's common difference, then you say D equals for common difference. And similarly here, you can see that you're multiplying by 1/2. So you can say the common ratio is 1/2. You can say multiply by 1/2, and so on. So please make sure you take notes. Next is, given the following information, determine the explicit equation for, so we're looking for explicit, okay? And it's good on the quiz or a test or even homework to highlight, you know, determine the explicit. This is what we're being asked to do, right? So we want the explicit. We know the common ratio is 2, the first term is 8. So explicit goes like this: f of n equals f of 1, which is 8, multiplied by what? Multiplied by 2 to the r to the n minus 1, which is 2 to the n minus 1. Now someone asked me, do we have to put this dot, right, to show multiplication? The reason I like it is because sometimes we don't even write parentheses, right, which I always urge you in class. If you remember, I said it's a good practice to put a parenthesis around the common ratio, because if the common ratio is a fraction, then especially a fraction with 1 in the numerator, then the n minus 1 technically applies only to 1, to the numerator. But here, what if we don't have like the dot and we don't have the parenthesis, right? It's gonna look weird, right? If you did that, it's gonna look like 82 almost, right? So these are good practices that helps you write mathematically in a correct mathematical way, I would say. Number 2, and then I'll let you do number 3 on your own. Also, again, we have f of 1 is 4. We have f of n in terms of f of n minus 1. So we have a kind of recursive, right, relationship here, without n greater or equal to 2, which you need to write every time. Don't forget that. So for explicit, we would say f of n equals f of 1, which is what? Which is 4, multiplied by, the common ratio is this guy, because 3 multiplied by f of n minus 1 gives you f of n, means the common ratio is 3. Multiply by 3, and again to the n minus 1. Okay, try 3 on your own, and we'll discuss when I'm back in class, okay, or when I'm in class, we'll talk about the answer for 3 if you need that information. Now, moving on to the next part, it says, below you are given various types of information. Write the recursive and explicit functions for each geometric. So here's the thing, for the test, for the upcoming test, you are expected to be able to generate or produce the explicit and recursive formulas for arithmetic geometric sequences from different types of information. Whether you're given a table of value, you're given a sequence of numbers, you could be given a word problem with you know, a scenario, and you could be given a pattern, right, or a graph like a pattern, dots or so, and you're expected to know how to come up with all these formulas. So for the first question, we have a sequence of number, and we can see we have a geometric sequence with a common ratio of 2. All right, so in this case, we know the common ratio is 2. If I were to start with explicit, the explicit formula states this. It says f of n. Remember, the explicit formula doesn't have f of 1 in it, right? So it's f of n equals, or actually doesn't have, sorry, I apologize. Scratch that. The explicit formula doesn't have f of n minus 1 in it, right? So f of n equals f of 1, which is 2, multiplied, that's f of 1, the first term, f of 1, multiplied by what? The common ratio to the n minus 1. The common ratio is also 2 to the n minus 1. So this is your explicit. Recursive always starts with f of 1. Always. So you always have to state f of 1 first, which is 2. And then you would say f of n equals f of n minus 1 times 2. And then you would have to state for n greater or equal to 2. I should have put this information down here. I missed it, but it's fine. So that's for the first example. For the second example, you can see that the first term is 3, and your common ratio is 2. You're multiplying by 2 every time. So this will give you, to start with, explicit f of n equals, right, the first term, which is f of 1, which is 3, multiplied by the common ratio, which is 2 to the n minus 1. For recursive, you always start with f of 1, which is 3, and then f of n equals, recursive, remember, it relies on the previous term, so it's f of n minus 1 times 2 for n greater or equal to 2. Okay? So again, f of 1 is 3, the first term is 3, f of n is f of n minus 1, and you're multiplying by 2 for n greater or equal to 2. So keep this in mind. All right, so try numbers 3 and 4 on your own, given the scenarios that you have here. And then for number 5, I also would like you to try it on your own, but I want you to first, when you have a pattern of this form or any form of pattern, always document the number of items that the pattern shows. So for instance, in this case, you have 6, and then this is a 3 by 4, which is 12. And this is a 3 by 2, 4, 6, 8, that's 24. And you could see you went from 6 to 12 to 24. So you're technically saying f of 1 is 6, right? F of 2 is 12. That's what you're saying. F of 3 is 24. Or for those of you who prefer tables of, n and f of n, you're technically saying the first term is 6, the second term is 12, right? The third term is 24. That's what you're saying. And you could see that the common ratio, which is 12 divided by 6, or 24 divided by 12, and your common ratio is actually equal to 2. It's a jump, right? Quote unquote jump. So for explicit, you would say f of n equals f of 1, which is 6, multiplied by the common ratio, which is 2 to the n minus 1. For recursive, you would say f of 1 equals to 6, and then f of n equals f of n minus 1, and then multiply by 2 for n greater than or equal to 2. Okay, so keep that in mind. So try to continue working on this packet on your own. And I would like you to remember, this is review. So I would like you to finish this review. Some of the questions may be like 29, may be challenging. So what I want you to think of, because it's challenging to see how do I go from 5 to 8 and then to 12.8, right? So what I want you to think of when you have, it's not arithmetic, because if you were to add 3 here, by adding 3 again, you don't get 12.8, right? So you have to be careful with that. And now you may say, okay, so what do I multiply by if it's multiplication? To know that, you can see if 8 divided by 5 is the same value as 12.8 divided by 8. And it should be the same, okay? And that should be, I believe, 1.6. So it should be 1.6. And this is a common ratio. This is an indicator that you have a geometric sequence with common ratio, and this is geometric with common ratio of 1.6 or 8/5, okay? So does it matter? No, you can write either one of them. You can use either 8/5 for the common ratio or 1.6. Either way, it's fine. The explicit, you would say f of n equals f of 1, which is 5, multiplied by, I personally like to use fractions, so it's 8/5 to the n minus 1. Now be super careful. You're not going to cancel this 5 with this 5, okay? Because the 5 inside the parenthesis is protected by the n minus 1 exponent. So this stays like that, okay? You're not canceling, you're not simplifying, it cannot be simplified. It would be incorrect to simplify that. For recursive, you would say f of 1 equals to 5, and then f of n equals f of n minus 1, multiplied by what? The common ratio, which is 8/5. And then for n greater or equal to 2. I hope I did not forget n greater or equal to 2 for the previous one. So it's always for n greater or equal to 2, okay? So try to complete this, the rest of this. You're to complete in class up to 30, page 30 and 31. That should be, let me see real quick. No, 31 is homework. So in class, try to complete up to page 30. And it's review. You can see it's the same information over and over again. And get started on your homework. And I will see you next time. Okay. You guys have a good one.